Now that you understand how to enter and start up your spacecraft, it's time to talk about one of the most important systems your ship has to offer. In this chapter, we'll be reviewing the power systems of your SHW Corporation X-Wing transport, which comes with 24 massive antique solar panels, as well as old-fashioned radioisotope thermoelectric generators, and enough lithium-ion batteries to get you through any eclipse. As you learned in Chapter 1, your ship is equipped with a microwave, coffee maker, CD player, television, mini fridge, 5 LCD screens, and a life support system to keep you alive. In order to produce enough power, your ship is equipped with 24 solar panels located directly beside the fuel tanks. These panels will automatically rotate towards the nearest star in order to maximize efficiency. Since you're probably used to the more modern fusion reactors found in other ships, let's do a quick rundown of these panels. They work by the photovoltaic effect, where an electron is excited by light, photons, and moves through the material, creating electricity. In solar panels, this is done using silicon, which has been doped with phosphorus, N-type, and boron, P-type, to create excess electrons and a deficit of electrons respectively. When put in layers and exposed to light, the N-type silicon will lose some of its electrons due to the photovoltaic effect, and they will then move down into the P-type silicon. This movement creates an electric charge. In fact, solar panels in space produce more energy than on a planet due to the lack of atmosphere, which would normally scatter and diminish the light coming from the star. That's why these solar panels can produce up to 130 kilowatts of power when in full light at 1 AU from the sun. Note that this will change based on a star's power output, distance, and your angle to the star. Taking a trip to Uranus? Well, your solar panels might not be enough out there. That's why your ship also contains 4 radioisotope thermoelectric generators, or RTGs. These RTGs use the Seebeck effect, also called the thermoelectric effect, to create electricity. Since plutonium-238 is radioactive, it steadily releases heat and large amounts of radiation, with only a very slight dose of radiation. No chance of radiation exposure whatsoever. By heating up one side of a circuit containing P and N-type silicon, the hot electrons will move to the colder side, which is cooled using the ship's thermoregulation system, which has been discussed in Chapter 7. This movement of electrons creates electricity, and since the RTGs contain 40 kilograms of plutonium each, they will altogether generate a steady 6 kilowatts of power. Even better, the supplies only need to be topped up once every 25 years. In addition to the RTGs, which provide power continuously, the Starship is equipped with a large bank of lithium-ion batteries, which altogether can store up to 300 kilowatt-hours of electricity. That's enough to power the life support, fridge, screens, and the television for over 24 Earth hours straight, even assuming a complete loss of solar panels and RTGs. Suffice to say, you'll never run out of power in this bad boy. And yes, this technology is almost exactly the same as what they would have used 500 years ago in the 21st century. Even in such primitive times, their engineering capabilities were astounding. If you look at the solar panels, the energy you use to make coffee starts out as nuclear energy in hydrogen atoms deep within a star. When 2 hydrogen atoms fuse to make helium, they release a large amount of energy in the form of light, which then travels through space about 150 million kilometers, or 1 AU, and strikes the solar panel. The photovoltaic effect then turns that light energy into electrical energy, and the electron moves down the wiring into your coffee maker, which heats up the water and lets you enjoy a nice cup of joe. With the RTGs, your energy still comes from the nuclear bonds in the plutonium-238, but is released as thermal energy, or heat, as the material decays. This heat will then induce an electrical potential, as we discussed earlier, which creates electricity. If going into your lithium-ion batteries, this electrical energy is stored as chemical potential energy, ready to be used whenever the main generators are not available. In conclusion, the power systems on the X-Wing are safe, reliable, and can provide more than enough power to meet your daily needs. Please note that due to safety concerns, interstellar travel using the X-Wing is not recommended, as being stranded in interstellar space without a fusion reactor is a near-death sentence. Besides that, have fun, fly safe, and enjoy visiting the moons of the solar system. Hold on, that's no moon.